Hello, this is, in this video, we are going to discuss the solution of a very interesting problem. The problem is to find a formula for the general term of the sequence whose first element, whose first term is 1, the second one is 2, the third one is 2, then 3, 3, 3. Notice that the 2 is repeated two times, and then the 3 is repeated 3 times, and then the 4 is repeated 4 times, and so forth. The 5, of course, we can expect the 5 to be repeated 5 times, and so forth. So, but before showing you how to solve this problem, I want to share with you a very important thought of George Polya. Well, George Polya was an Hungarian-American mathematician, a very important mathematician that wrote a lot about techniques for solving problems. I mean, problem-solving techniques. And then he said the following, or he wrote in one of his most important books, the How to Solve It is the name of that book. He wrote this idea. If there is a problem you can solve, then there is a simple problem you can solve. Find it. Well, what is the meaning of that? This can be considered as a very important technique to solve problems. It means when you don't know how to solve a complicated problem, you need to try to find a related problem which is going to be simpler for you. And then by solving that problem, you can learn a lot about, in some cases, of course, you can learn a lot about how to solve the more complicated problems. So it means that this is an interesting idea here. And then that we can see that we need to use this idea again and again and again when we are solving problems. We have to find a formula for this sequence. Or what is the same thing? I mean, the same thing is just to find a formula for the general term of this sequence. And again, notice that the 1 is repeated only once, the 2 is repeated twice, the 3 is repeated 3 times, the 4 is repeated 4 times, the 5 is repeated 5 times, and so forth. We can expect the 6 to be repeated 6 times, the 7 times, and so forth. Now, we are going to focus on a simpler problem. Before trying to start solving this problem, let's try to learn the most we can from a simpler problem. And a simple problem in this case can be this one, can be, for example, find the formula for the general term, of the sequence. Let's take this sequence here. The sequence whose terms are 1, 1, 2, 2, 3, and 3, 4, and 4, and so forth. Notice that every term is repeated twice. Every term is repeated twice. Of course, in this case, we are going to consider that the first element is a sub 0, the second one is a sub 1, a sub 2 is the third one, a sub 3 the fourth one, a sub 4, and so forth. So the idea here is to assume that a sub n, when the n is a number greater than or equal to 0, can be expressed in this way, can be expressed like the floor of a certain expression that depends on n. Okay, and then according to what we will need to get here, one possible expression for f of n that we can consider here can be the following. Let's say the one that when you evaluate at 0, you get 1. When you evaluate among many other possibilities, this is one possibility, that when you evaluate at 1, you get 1.5. So therefore, the floor of f sub 0 is 1. The floor of f of 1 is 1 also. then f of 2 is going to be equal to 2, f of 3 is going to be equal to 2.5, and so forth. You can see that f defined in this way is a linear function, and then it's easy to find a formula for that linear function. You can see that the slope of this linear function is, or what is the same, the average rate of change of that function is 0.5. And then the formula is going to be like this: f of n is equal to 0.5 times n plus b, but when the n is 0, you need to get 1. When the n is 0, according to this here, when the n is 0, you need to get 1, and therefore you need to add 1 to this expression. So then this is going to be the formula for f of n. And now it is easy to check. This is easy to check that whenever you find the floor of 0.5 n plus 1, you always get that this expression a sub n defined in this way is going to be the expression, or a formula for that sequence. A formula for that sequence. You can check here that, for example, when the n is 0, 0.5 times 0 is 0, plus 1 is 1, the floor of 1 is 1. But when the n is 1, 0.5 times 1 is 0.5, plus 1 is 1.5, the floor is 1, and so forth. Now, but let's try to get even more information, because we can use this idea with the problem that we are trying to solve with this problem. But notice that in this case, the difference, the fundamental difference between this problem and the one that we already solved here is that the number ones is the same, the number of twos is the same, the number of threes is the same, but the number of each one of these value here is increasing. The number of twos is 2, the number of threes is 3, and so forth is increasing. So I don't think a linear function is going to solve our problem. But let me try to continue thinking about this simpler problem and to see if we can devise a method that can help us solve the more complicated problem better. Notice that, well, in this case, we have the following. We have that f of 0 and f of 1, they both are greater than or equal to 1 and less than 2. F of 0 and f of 1 are both greater than or equal to 1, less than 2. Then f of 2 and f of 3, they are both greater than or equal to 1, less than, greater than or equal to 2, sorry. Greater than or equal to 2 and less than 3, less than 3, greater than or equal to 2, less than 3, and so forth. Now let's try to use this idea to try, to try to express it in general. It means that f evaluated at n must be greater than or equal to k and less than k plus 1 for what values of n? Notice that here, when the k is 1, the values of n are 0. When the k is 1, the values of n are 0 and 1. When the k is 2, the values of n are 1, 2 and 3. When the k is equal to 3, n has to be what? 4 and 5. Notice that the first element is always an even number, and the second is the following number. So it means that this happens when the n is greater than or equal to, and what is the relation between the value of k and the first number here? Well, notice that when k is 1, you get the first number is 0. When the k is 2, you get 2. When the k is 3, you get 4. So it is easy to find a pattern here, to find that the smallest values of the n must be 2 times k minus 2 to express it as a formula in terms of k. And then this is going to be less than what? The number 2k. Well, we have 2k minus 2 and 2k minus 1. Then the next number is 2k. So it means that the n must be in between 2k minus 2 and 2k. Whenever the n is in between 2k minus 2 and 2k, we are going to have this. But now notice that we can represent this with a function. We can define the function. We define the function g of x equals 2x minus 2, defined for all real numbers greater than or equal to 1, where the x is greater than or equal to 1, then we can rewrite this expression in the following way. The g evaluated at k is less than or equal to n, and then this is less than g evaluated at k plus 1. Notice that when you evaluate this function at k plus 1, you get what? You get 2k. Now, notice that this function, the function g, is increasing, strictly increasing, and then it is 1 to 1, so it has an inverse function. And we can find that inverse function, you know, that you can find the inverse function by doing y is equal to 2x minus 2, then interchanging the x and the y. X is equal to 2y minus 2, then the x plus 2 is equal to 2y, then x plus 2 divided by 2 is equal to y. And let me denote this function by f. F of x is, which is the inverse function of g of x, can be expressed like this, and this is nothing more than 0.5x plus 1, which is the same function that we had before. And therefore, if you apply this function, which is the inverse of g, to the three sides of this inequality, we are going to maintain, you can maintain the inequality. The inequalities are going to keep to be kept being true. Why? Because this function is increasing. If the original function g of x is increasing, f of x is also increasing, but it's something that you can see here very easily because this is a linear function. And then it means that if you apply f to the three sides of this combined inequality here, you get the following. So, I mean, we are applying f to all the sides of this inequality, and then here you have f of n is less than f of g of k plus 1. This is true due to the fact that f is increasing, but remember, if f and g are inverse of each other, you get here k is less than f of n, and this is less than k plus 1. But remember, this always implies what? This always implies that the floor of f of n is the number k. And this is exactly what we need. Whenever the k, we need to this is what proves that this formula works in this case. So actually, we have checked this before because this is f of n is the function that we consider before. Okay, the same function, the linear function that we consider up here, okay, is that function. So a sub n equals the floor of 0.5n plus 1 is a possible formula for that problem. And then this is the solution of our problem. Again, the solution is a sub n is equal to the floor of 1/2 times n plus 1. This is the solution for that problem. This is the formula, a possible formula for the simpler sequence, for this sequence here that we introduced. Now we are going to try to use now the same idea for this more complicated example. We're going to try to use the same idea for the more complicated example here. And now solving the original problem. And then we can see the following. Notice that the value, the a sub 0, is equal to 1. And then in this case that, well, this is true that a sub 0 is equal to 1. And then now a sub 1 is equal to a sub 2 is equal to 2. a sub 3 is equal to a sub 4 is equal to a sub 5 is equal to 3. A sub 6 is equal to a sub 7, which is equal to a sub 8, is equal to a sub 9, is equal to 4, and so forth. So I want you to notice the following. Well, how can we express this in general? Well, notice that, well, these numbers, the first number here, the first index from the left to the right, for any of one of these lists of numbers, they have a pattern. Notice that the pattern of this sequence 0, 1, 3, 6, the next one would be 10, and the next one, if you continue adding elements here, you're going to get, so this is going to be 15. It's going to be the next one, 15. And now notice that these numbers can be expressed using the following formula: k times k minus 1 over 2. K times k minus 1 over 2. And notice that the last number is less than k plus 1, k times k plus 1 over 2. So it means that whenever the n is in between the last number of one of these lists in the same row here is 6, when this number, when k is equal to 4, the value of k times k minus 1 over 2 is equal to 6. And when k is equal to 5, you get 5 times 4 over 2 is equal to 10. But notice that the numbers here go from 6 to 9. You can see that when for any value of k, when the n is greater than or equal to k times k minus 1 over 2 and less than k times k plus 1 over 2, this must imply that the a sub n, where the a sub n represents the general term of that sequence that we are discussing now, must be equal to k. But if we assume that this sequence, that the a sub n can be expressed as the floor of a certain function f evaluated at the number n, then this must be equal to k. And this must imply then what? That the f of n is greater than or equal to k, the number k, and less than k plus 1. So basically what we have to do here to get the corresponding formula for that given sequence is to find an expression for this formula for f of n. That's basically what we need to find here. But how can we do it? We can do it in a similar way to what we did for the previous example. It means first we're going to introduce a function that is going to be equal to x times x minus 1 divided by 2, where the x is greater than or equal to 1. Well, this function, if you graph it, you see that the graph of this function looks approximately like this. It's like part of a parabola, but a part of a parabola that starts at the point 1, 0, and it increases. Now, notice that this form on the left side of this inequality is nothing more than g evaluated at k. G evaluated at k. Now we are going to find the inverse function of the function g. How can we do that? Remember, well, you know the procedure from pre-calculus or from college algebra. If you have taken any of these classes, so y, you replace first the g of x by y. Y is equal to x times x minus 1 divided by 2, where again we know that the x is greater than or equal to 1, and we can see easily also that the y greater than or equal to 0. Now, we are going to interchange the x and the y. The x is y times y minus 1 divided by 2. And of course, we have to interchange the inequalities now. So the y must be greater than or equal to 1. The x must be greater than or equal to 0. And now what we have to do is to solve this equation for x. After manipulating that equation, we can transform that equation into the following quadratic equation. So multiplying both sides by 2 and then bringing all the terms to one side and changing the signs if you need it, you get this equation. And remember that y has to be greater than or equal to 1, and the x must be greater than or equal to 0. Now we are going to solve this equation using the quadratic formula. Then using the quadratic formula, the y is going to be 1 plus or minus square root of 1 plus 8x all over 2. Again, where the y has to be greater than or equal to 1, the x has to be greater than or equal to 0. But for the y to be greater than or equal to 1, you cannot choose here the negative sign, this negative sign. You have to choose the positive sign only. So it means that the y has to be 1 plus square root of 1 plus 8x all over 2. And this is defined where for values of x greater than or equal to 0. So this means that the inverse function of the function g is the function f of x. We are going to use f to denote this function, which is 1 plus square root of 1 plus ax all over 2, and which is defined for all values of x greater than or equal to 0. Now, going back to the inequality that we had before, we have that the n, whenever the n is greater than k times k minus 1 over 2, and this is less than k times k plus 1 over 2, then we can rewrite this inequality in terms of the function g that we introduced. You can see that the left side here can be expressed as g of k, and the right side in this inequality, the rightmost side here can be replaced by g of k plus 1. Now, as you can see that the function f is increasing. Actually, if you graph the function f, you're going to see that the graph of the function f is approximately like this. Remember, the domain is, it goes from 0 to infinity, including 0, and the range includes the number 1. So this point here is the point 0, 1, and it's increasing. And therefore, as it is increasing, you can apply f to the three sides of these combined inequalities, and you get the following. It means you can keep the order here because the function, because of the fact that the function is increasing. But now f of g of k is what? As the two functions are inverse of each other, this is going to be k, and here the same thing, f of g of k plus 1 is k plus 1. And basically we have obtained exactly what we needed. It means we needed to get that f of n has to be greater than or equal to k, less than k plus 1. So it means in this case, for the function f defined in the way that we did it before, this has to be true. It means that whenever these two combined inequalities are true, it means the n is in between, is greater than or equal to k times k minus 2, but less than k times k plus 1 over 2. The floor of f sub n, f evaluated at n, is going to be k. Therefore, the solution, the answer to our question is going to be the following. The answer is going to be that in this particular case, a sub n has to be equal to the floor of 1 plus square root of 1 plus 8 n all over 2. And this is going to be the the formula for the general, well, a possible formula for the general term of the given sequence. So of our original problem. Now, I'm going to finish this video sharing a similar problem with you. I hope that you are going to take time and solve this problem. I would really appreciate if you put your answers in the comments of this video. And well, the problem is the following. So this is a problem for you to solve it. If you find the general term, please put the general term in the comments here. Find a formula for the general term of the sequence 1, 2, 2, 2, 3, 3, 3, 3, 3. Notice that in this case, the 1 appears only once, the 2 is repeated 3 times, the 3 is repeated 5 times, the 4 repeated 7 times, and then you can see that there is a general pattern here that then the n in general is going to be repeated 2 times n minus 1 times. 2 times n minus 1 times. And this is it for today. This is the end of this video. I hope that you enjoyed the video, and see you in my next video.